Effective disease management begins with some basic concepts. We cannot skip this initial step of understanding what drives disease. So today we're going to begin with the most basic of all plant disease or plant pathology knowledge is the disease triangle. So I'm calling this Plant Disease 101. So the overall concept here is that in order to have disease, three things must be present. There must be a pathogen. Those are the microscopic organisms like fungi, bacteria, viruses, nematodes that actually infect plants. We must have a susceptible host. So that's either the host crop or a host cultivar. But there must be a susceptible host or else that pathogen cannot infect. And then thirdly, there must be a favorable environment. So environmental conditions like moisture and temperature must be within a certain zone in order for that pathogen to be able to infect, produce spores or to reproduce, and then to infect new host tissue. So all three of those components must be available in order for disease to occur. And if you think about it in that same way, breaking the disease triangle will manage disease. So eliminating the pathogen, using a non-susceptible host, or altering environmental conditions can help break the disease triangle. So as we go through these general steps, keep in mind, think about ways that you'll be able to manipulate the disease triangle in order to manage diseases on your farm or in your landscape. Now, I will mention that these concepts apply to any type of plant or plant disease and any type of scenario. So all of the examples here, or the pictures anyway, are of vegetables, but this is not restricted to vegetable production. So let's start with the first side of the disease triangle, the host plant. And the host is whatever it is that you are growing and whatever it is you are trying to protect. So when we talk about host, we can talk about the whole plant, or we can talk about specific plant parts, leaves, stems, trunks, roots. Sometimes we're really specific and we say new growth, for example. This powdery mildew in this image here infects new growth before the cuticle gets thick. So sometimes it's a type of tissue within a susceptible host. Overripe fruit, that's another one in apple diseases, for example, in blueberry diseases, grapes. So when we talk about host, we might mean the entire host, or we might mean specifics of a susceptible host. So in order to manage disease, we always start with resistant plants, or really the word is tolerant. So nothing's really resistant. There are non-hosts, but within a genus, we have often cultivars, different species, and there can be resistance built in there. Plant breeders often breed not just desirable traits, but also disease resistance. Again, genus, species, cultivars. And for those of you familiar with the publication we call ID 36, that is our vegetable production guide for commercial growers. There are sections within ID 36 that describe resistant and susceptible hosts. And here's just a snapshot from that ID 36 as an example. This is a page from the tomato section, and within these cultivars, we're seeing mentions of where resistance, whether it's to certain races, for example, of fusarium, or different types of diseases. So that is listed not just in ID 36, which is a great place to start, but in your seed catalogs and seed packets, it's usually listed there. And again, we're talking about vegetables in general, but there is some resistant root stocks for some diseases in apple, for example. So across all crop groups, there is resistance or not. Some diseases we do have resistance for others we do not. But some of the worst ones, especially in annual crops, a lot of times we will see resistance built into to information on seed packets and in some of our production guides. Okay, let's continue on talking about the host. So we know about resistance, but what about plant vigor? So think about a wounded plant or a stressed plant is more susceptible to infection. So maintaining plant vigor will help reduce, minimize, or even avoid plant diseases or that infection. So maintaining plant vigor, very important. So wounding is a big one, and I just want to drill down on that a little bit. So a wound is an open door for a lot of these microscopic pathogens to enter. So any kind of wounding, and here we've got a plow that nicked this onion, but wounding can also occur from insects, from weather. So whether it's sun scald or frost cracking on woody plants, so wounding can occur in a lot of ways, and there are also, of course, natural wounds. As plants grow, they develop openings that pathogens can enter. If we have woody plants, for example, we're doing some really major pruning every year or twice a year. So thinking about wounding from that aspect, when can you prune to encourage the fastest healing or callousing? But unnecessary wounding should always be avoided. So think about that when planting, when maintaining crops, and also when harvesting. Okay, and when we talk about vigor, maintaining vigor, we're reducing stress, and stress can come from a lot of directions. We're going to talk about environmental conditions soon, drought stress, nutrient deficiency, improper pH. Anything that doesn't have that plant at its best makes it more susceptible to a lot of plant pathogens. Excessive growth. So we talk about vigor, we want vigor, but excessive growth invites infection as well. So we have the opposite end of that spectrum. So over fertilization is very common mode for excessive growth, which is an invitation to infection by plant pathogens. All right, now we're moving to the next side of the disease triangle, the environment. Remember, that was the bottom leg on the image that I showed you earlier. So environmental conditions include moisture. I always call it free moisture. So free moisture can be everything from rain to irrigation, humidity, fog, dew. It can also be soil moisture, so surface soil moisture and internal soil moisture. And then temperature. Temperature is a little bit tricky because I always say, if I'm comfortable, the pathogen is comfortable. So those kind of moderate temperatures are usually where our pathogens are happy in general. So if it's too hot, our pathogens will become inactive. If it's too cold, our pathogens will become inactive. So think about yourself, right? When are you the happiest? Usually it's in that 70 to 78 degree range. That's usually that window, 68 to 78, where our pathogens are the happiest, but there are exceptions across the board. So for the sake of generalizing here, think about if you're comfortable, the pathogen is comfortable and it's more active, but then we've got the both sides of the spectrum. So you add moisture or that free water with moderate temperatures, and you've got the perfect storm for a plant disease to develop. So let's start with site selection. And this matters in terms of environment because a site is going to dictate temperature and moisture, available water to an extent. So wider plant spacing will help air circulate. And when we circulate air, we're drying that air out. We're replacing the humid air in a canopy or between canopies, for example, with some drier air. Same thing goes with pruning. When we prune, we improve and increase air circulation, and that is simply to reduce humidity. Let me make a side note here. Humidity above 70% is usually ideal for plant pathogens. Most of our fungi, 70%. All right. Some of our water molds, some exceptions to fungi, and our bacterial pathogens, it's usually 85% relative humidity. So we're trying to bring humidity down. Yes, this is Kentucky. Yes, we do have very humid days. We have humid evenings. We have fog and dew. I understand that. But the more we can do to circulate air, we're displacing humid air in canopies, under and between canopies. Don't forget also about microclimates. Microclimates can be the edge of a field, maybe that's lower. It could be maybe part of a field that has afternoon shade as a result of a fence row or a tree canopy. It could be, if you're in a landscape, it could be against your house. So think about microclimates that would be cooler in the summer, maybe wetter, or even more humid. Those matter, right? So just because we say, oh, it's been 95 degrees for 2 weeks and we haven't had rain, that you won't have a microclimate that doesn't have those cooler temperatures and that free water. All right, so continuing on with site selection, drainage, surface drainage and subsurface drainage are absolutely critical when we're talking about crown rots and root rots. So our canopy humidity will affect the upper plant parts, and our soil moisture is going to affect our lower plant parts. So good drainage, raised beds, raised rows, always very important. So as much as you can raise that. So more internal drainage, more surface drainage will help reduce the moisture in a lot of crops, protect those crowns and roots. Selecting a site with loamy soil instead of clay, using drip irrigation instead of overhead irrigation, those all contribute to moisture levels. Drip irrigation prevents that wet foliage. Loamy soil improves drainage. So think about that excess water, right? That free water that really will drive plant disease. How can you lower it? How can you manipulate it just a little so that your risk is lowered? Okay, the pathogen. That's the third side of the disease triangle. I saved this one for last. So plant pathogens, as I mentioned earlier, are fungi, water molds. So water molds are fungus-like, but they're not exactly fungi. So we'll use different fungicides for them. They require more water to complete their life cycle, but they are similar to fungi in a lot of other aspects. Bacteria, viruses, and nematodes. Those are all plant pathogens. Plant pathogens will infect. Plant disease is the symptom. It's the reaction by the plant. So the anthracnose that you're looking at here on this bean, so the anthracnose is the disease. It's the symptom. But the pathogen is the fungus that has infected this bean. Okay, so when I'm using those terms, I'm not using them interchangeably. So infection can occur days, weeks, and in terms of woody plants, months before we see symptoms or months before disease develops. All right, so let's talk about pathogens. What do we do? How do we use that side of the disease triangle to manage disease? Well, first of all, ideally, we're excluding the pathogen from our farms, from our fields, from our greenhouses, high tunnels. We're excluding it. Don't let it in, right? Now, of course, this is often pie in the sky when it comes to fungi with spores that move long distances on air currents. But there are a lot of our plant pathogens that we physically move. Soil-borne pathogens are an example. So to exclude pathogens from your farm, we're starting with clean plants. We're not buying discounted plants. We're examining plugs and flat trays when they arrive. We are not accepting anything but clean plants, disease-free plants. They can't come in. We're not putting them in the soil, okay? Because once these pathogens establish, it's really difficult, if possible at all, to get rid of them. All right, so we're starting with clean plants. We're checking the foliage, we're checking the stems, we're checking the roots. we're popping those plants out of the container and we're examining those roots. So we're not letting anything in. Even damaged, even physically damaged plants, wilted plants, broken plants. Sometimes those are indicators of something bigger. So ask lots of questions and really understand what comes off of that truck. Using certified seed when possible, or at least clean seed. So trading seeds with neighbors is good in theory, but a lot of times that's where we start introducing plant pathogens to farms that before didn't have major disease issues. Okay, so we are also using exclusion in a little bit different way. So if you have, for example, a soil-borne pathogen or a pathogen that overwinters on the surface of the soil or in the soil and then splashes back up the next spring or the next growing season, we can use things like mulch, whether that's plastic mulch or an organic woody mulch, straw, hay. Straw is usually a bad idea. Oh, sorry, hay is usually a bad idea if it's got weed seeds, but straw. So anything that would create a barrier between the bare soil and plants will help prevent splash. Also, in that same concept, sanitation. And we can have a whole lecture on sanitation, and I'm unfortunately only mentioning it here. But sanitation simply means clean. So when we're talking about keeping things clean, we're cleaning things before they go to the field, but our fields also need to be clean. So we're clean picking, right? When we go out to harvest, we're using two buckets. We're harvesting our marketable produce in one bucket, but our diseased and damaged produce is coming off of the plant and it's going into a discard bucket and it's leaving the farm or it's leaving that field or that greenhouse or that high tunnel or whatever it is, because dropping diseased produce on the ground is simply going to let that pathogen overwinter or over summer, and it will be back the next year. So sanitation, keeping things clean, clean picking, roguing infected plants or diseased plants, getting them out of there. So keeping things clean will prevent that splash or that movement of pathogens the next season, right? So the previous slide, I talked about not letting it onto the farm. And then this slide is more from the aspect of, if it is on the farm, how can you keep it off of your plant, right? So we're creating a barrier or at least roadblocks to slow or prevent that movement of that pathogen to your produce. All right. A concept that some of you may have heard at this point, we call it a green bridge. And a green bridge is simply a plant not favored per se by the pathogen, but it's that space that holds the pathogen until your next crop goes in, right? So a lot of times volunteer seedlings or even weeds can serve as a green bridge between crop cycles. If you have a greenhouse, a lot of times that's any leftover plants if you didn't completely fallow, or weeds between the cracks in the pavement, or if you're in a traditional field, that would be either weeds or any kind of volunteers that are left. So beware of green bridges, because you can't break a life cycle if green bridges are in place. For fruit growers, we also talk about the word mummies. Mummies are small dried fruit that hang on the trees or hang on the shrubs, for example, and they will be a source for inoculum for the next year when, for example, that peach leaves back out or those blueberries leaf back out. And so then those mummies will be that source for inoculum. And then finally, debris. So this is kind of touching on that sanitation again. Debris is anything that is left in the field or falls down and is not cleaned up. So leaf diseases will overwinter in leaf debris. Stem diseases will overwinter in stems, and fruit diseases will overwinter in fallen fruit or fruit mummies. So anything on the ground needs to be cleaned up. In an ideal world, we're cleaning everything up and we're mulching everything perfectly. But in a real farm situation, we're not able to do that. But if you think about sanitation and think about debris. How could you get as much debris out of the field between crops? How can you clean pick? When you're pruning or when you're terminating a crop, do it straight onto a wagon or straight onto a tarp. Don't throw things on the ground and try to pick it up because more debris stays behind. If you're in a landscape, can you rake? What can you do? Right, especially when there's a disease outbreak. That's when it's really severe, right? So ideally we would do this for everything all of the time, but that's not realistic. But when there is a disease outbreak, when there's a disease that's really causing yield losses, all of these extra steps must be adopted, and you must be more careful, more diligent when there's an outbreak. Okay, we're still talking about exclusion. Um, Cankers. Let's talk about the word canker. Canker is simply a lesion on a stem or a crown. All right. So if it's on a branch or a stem, it looks different than, say, a leaf spot. But if you are purchasing plants, look for cankers, not just leaf spots or leaf diseases. Always look for cankers. And then earlier I talked about roots. So a canker is just a stem lesion, but look at that soil level. All right. Even when you're scouting your own field, always look at the soil level. There are a lot of things that soil level will tell you. Okay, now I'm switching gears. So I went from prevention. Now we're going to try to look at management after we have disease in our field. We're going to call this eradication. It's the word we use, but in reality, we never really eradicate. Okay, so eradication is not a real thing. We're reducing, we're controlling, or no, we're managing, not controlling. Sorry about that. So when we eradicate or attempt to eradicate, we're moving in that direction. We're aiming for cankers, dead, dying, diseased tissue, rotted fruit, dead plants, dying plants. So we're getting those out. And I mentioned that earlier when I talked about debris. This is the same thing. Dead, dying, diseased tissue has to go as soon as possible because it's that diseased tissue that's going to generate fungal spores, bacterial cells, and that inoculum that's going to infect nearby healthy plants or overwinter for the next season's crop. All right, so back to our debris conversation, right? So when we're eradicating debris, we're getting out cuttings, clippings, prunings. I said earlier, pruning right onto a cart or right onto a tarp. You can drag a tarp between rows very easily. So the smaller the debris is, the harder it is to pick up. The more brittle it is, the more easily it's going to break and stay behind. So cleaning up debris, handling it once, it's going to save you time and money, but it's also going to assure that you're getting things out of the field or out of the greenhouse or out of the high tunnel. All right. So we also spread, we as humans also spread disease, right? So plants, movement of plants, yes. Our fungal spores, a lot of times fungal spores can be airborne. They can be rain splashed. Bacteria also rain splashed, move with debris, but we also can move through debris that sticks to us, sap, etc. So cleaning your tools between uses. I like either scrubbing bubbles, and so it's got that soap, it cleans, especially it's really good for sap. It won't corrode your pruners or your tools, and then it has that antimicrobial built into it. If not, you can do something like a Lysol concentrate. Larger growers will use a commercial disinfectant, which are also very cheap. We have a publication on that everyone will receive a link here in the description. Movement of soil, I kind of talked about it a little bit when I talked about debris, but any of the debris that breaks down or any of our soil-borne pathogens, all those propagules are going to be mixed in with the soil, right? So they're hitchhiking with soil. The bottoms of our shoes, the tires of our carts, anywhere we have mud or soil, a hose dragging through the greenhouse, those are all ways that pathogens can move around. They're moving with the soil. So when you're eradicating or attempting to eradicate, you're cleaning things in between blocks, in between fields, in between zones. So you're preventing that movement. Same goes for containers. If you're going to reuse containers, and some people do, I know we say a lot, never reuse containers, but the reality is small growers, especially those that want to save money, will be reusing containers. You're going to take that same approach as you did with your tools. You're cleaning it, you're washing it, and then you're disinfesting it. With containers, sometimes we could do bleach. Bleach is fast and it's super effective. I don't use bleach on my tools personally, but bleach works. Again, link in the description. And I talked earlier, as I talked about soil moving around in containers and in carts and tires. They're also moving with shoes. And before I leave this slide, remember, when you move a tractor or any implement between fields, always wash it. A pressure washer or a hose, it's better than nothing. And never ever borrow equipment from anyone without washing it before it gets to your farm. This is a way we introduce a lot of soil-borne pathogens. And once some of these really severe pathogens are introduced, they're nearly impossible to eradicate. Okay, so continuing with eradication, we're rotating crops. Okay, depending on the disease, sometimes we have to rotate for many years so that an overwintering pathogen will putter out. But the rule of thumb is 3 years. Okay, so plant 1 year, skip 2 years. A 3-year rotation should be standard for disease management across the board for all growers, no matter what you grow. And then again, if something severe moves in, we might make recommendations for 5 or 6 years. And there are some pathogens that can survive for 10 or 12 years in soil. So that's why we're really so adamant when we preach about sanitation. And then roguing means pulling out dying plants. Don't try to save them. Don't wait to see. Get it out of there before more propagules are introduced in your soil, before that inoculum is produced. So the faster you get it out, the better to protect current healthy plants and future crops. All right, so there we are. That's your introduction, Plant Pathology 101. Let's recap really quickly. The disease triangle is just a visual, so we can remember what is required for disease to develop. Remember, disease is a plant's reaction to an infection. Infections occur by the pathogen. The pathogen infects. Days, weeks, months later, disease will develop if there's a susceptible host and if the environmental conditions are right. That means what? Free moisture and moderate temperatures. So we can manipulate plant disease, prevent it, reduce it to acceptable levels by thinking about the disease triangle and manipulating any of those sides. Resistant cultivars, non-host, rotations, pruning and air circulation, good drainage, and of course, starting with clean plants, and then once we have disease, reducing that spread through things like sanitation and mulching. So what about fungicides? One thing I did not mention in all of these this time is fungicides. Why not? Because everything I talked about previously must come first. We cannot skip to the fungicide step. The fungicide step comes after we understand all of the concepts of those cultural practices. So now let's talk about fungicides. By the way, when I talk about fungicides, I'm talking about conventional synthetic fungicides and I'm talking about organic and biologicals. Okay, so fungicides is a blanket term here. So even if you're an organic grower listening to this, I'm still talking about organic fungicides, okay? Fungicides in general. Before we use fungicides, we must use all of our cultural practices, all of the tools in our toolbox. We're beginning with resistant cultivars. We're using cultural practices no matter what kind of farmer we are. We're timing our fungicides when we use them. We're timing them properly. That means we're using them preventatively. We're going to understand which diseases we're likely to have. We have lots of resources for you to help you with that. What diseases you're likely to have, and if you are going to have those diseases, you're using preventative measures, not waiting, because fungicides are not curative. Okay, you can't wait until you have disease and then spray a fungicide. They're preventative. Remember that bacteria and water molds are different from fungi. So when you use a fungicide that's aimed at fungal pathogens, you're not going to be controlling pythiums or downy mildews or bacterial spot or angular leaf spot. Okay, they're different. So really knowing what you have, which means that you should utilize your county extension agent and your plant disease diagnostic lab as much as possible so you really know what you're aiming to manage. Moisture and humidity, that's my favorite side of the disease triangle. We can really manage moisture and humidity by increasing air circulation. And then sanitation, sanitation, sanitation. We're using sanitation practices through the season and at harvest. So we're clean picking, we're roguing, we are trimming and pruning, and we're doing all of that onto a cart or a tarp, and we're keeping everything clean. We're cleaning our containers, pruners, equipment. We're not moving plant pathogens from one field or zone to the next. Okay, I'm closing out with one comment, is that if you are a high tunnel grower, your fungicide must be labeled for greenhouse use, because here in the state of Kentucky, the KDA considers high tunnels as greenhouses. So check your labels. Um, uh, uh, all pesticides used in a greenhouse or high tunnel must be labeled for greenhouse use. And we can talk more about that as needed, but that is something to remember if you are a high tunnel grower. That's usually a little bit of a frustrating point and maybe a point of a lot of confusion. So the label is the law. Read the label thoroughly always. We've got guides and resources to provide guidance for you, but always reading that label. So that label will always be the law. So with that, here are some resources. These our Department of Plant Pathology website has lots of resources, so take some time to spend with those. You'll see hundreds of resources there categorized by crop type. And then you can follow us on social media, where we're always posting some of the latest information, maybe what to scout for at different times of year, if there are outbreaks, new resources, that type of thing. So both on Facebook, Twitter, and our Instagram site is coming up very shortly. And then finally, subscribe to Kentucky Pest News. Once you go onto that site, you just enter your email address, and Kentucky Pest News is also a site to give you the latest information. So with that, thank you, and we will be in touch.